these are the notes for lesson 2.7, piecewise functions. The first part is sort of a review because we've talked about plugging in different values for x into equations. Notice here it says evaluate f of x equals, and there's two different equations. The first one is 2x minus 1, and that's when x is less than or equal to 3. The second equation is 3x plus 5 when x is greater than 3. So if we look at the domain for each of these equations, the first is x is less than or equal to 3. So if we think about the values that includes, it's or equal to 3, so that includes 3, and any numbers that are less than that. So 3, 2, 1, 0, and anything less than that. Our second equation, our function, 3x plus 5, is when x is greater than 3. There's no equal to, so 3 is not included. So this would be for 4, 5, 6, 7, and any number that is larger than that. So each of these functions has a different domain, so we have to make sure that we look at that value because that will determine which equation we use when we're plugging in for x. So the first one we want is to plug in x equals 4. So again, we have to look at the x values that we're given. So we want to know which equation is included in x equals 4. If we go up to our equation, we know that 4 is greater than 3. So we're going to use this second equation here, 3x plus 5. So we're just plugging in just like we would before. So f of 4, because 4 is the value that we're plugging in, 3 times 4 plus 5. 3 times 4 is 12. And 12 plus 5 equals 17. So x equals 4 is 17. Again, we use the second equation because 4 was included in those x values. So part B says x is equal to 3. So in this case, we're going to use the first equation, 2x minus 1, because that's where it fits in the domain. So x equals 3, x is less than or equal to 3, so we know that's the equation to use. So this is f of 3 is equal to 2 times 3 minus 1. 2 times 3 is 6. 6 minus 1 is 5. So again, when we have more than one equation, we have to look at our domain or the x values that they give us to determine which equation we're going to plug into. The definition of a piecewise function is where more than one equation is needed to represent a given situation. So multiple graphs pieced together will fit the function. So what we need to remember before we can start graphing piecewise functions is our open and closed circles when we are talking about inequalities. So if it's less than or greater than, that's when we have our open circles. We have our closed circles when it's or equal to. So less than or equal to and greater than or equal to. And again, that's going to come in very useful, and it's something that we need to remember when we are graphing piecewise functions. So the first example, we are graphing f of x equals, the first function is 2, and that's when x is less than 3. The second equation is x minus 1 when x is greater than or equal to 3. So again, we have to look at these two equations separately, or these two functions separately, and then we can graph them on the same graph. So the first one we have is f of x equals 2. Again, this is our first equation here. Think of this as y equals 2. Like we talked about before, f of x is the same as saying y equals. Okay, it's just another way of saying it. So this is the equation y equals 2. So that's the first one that we are going to graph. Now, we have to look, our x values are less than 3. So on our graph, the function f of x equals 2 is going to be anything less than 3 on our x-axis. So if we look at our graph, we're going to find x equals 3, and in this red shaded area is going to be the graph of y equals 2. So one way to help us graphing, remember that if a function is y equals, remember our hoivux. So horizontal is y equals. So we know that this is a horizontal line through y equals 2. So we can put a point at y equals 2. Again, we know that this graph starts at x is less than 3. Since it's not or equal to, at x equals 3, we're going to put an open circle, and then our graph is going to go to the left of that. Then we're going to look at our second function. F of x equals x minus 1. And for this one, it is x is greater than or equal to 3. So if we look at our graph, we're going to find x is equal to 3. It's going to be anything to the right of that. So our graph is going to be graphed in the blue shaded area that I just showed you on the graph. So to figure out what our graph looks like for this function, f of x equals x minus 1, One way would be to graph this as y equals x minus 1. We know that our slope is 1. We know that our y-intercept is -1. But again, the only part of the graph that we need is when our x values are greater than or equal to 3. So a faster way for us to do this is to set up a table of values. Again, the x values that we are looking at are anything greater than or equal to 3. So we're going to start with 3. If we plug in 3 for x, 3 minus 1 is 2. So our y value is 2. If we look at x is equal to 4, 4 minus 1 is 3. And we'll do one more since it's going to take us off our graph. If we plug in 5, 5 minus 1 is 4. And then all we have to do is plot these points, and that will show us where that part of the graph is. So 3, 2, we're going to go over 3 and up 2. Notice this is a point that we already had with the other graph, but it was an open circle. For this function, it is greater than or equal to, so we're going to put a closed circle there for this function. Then the next point is 4, 3. So go over 4 and up 3, and then over 5 and up 4. So that's going to be the second part of our graph. So again, notice we're graphing each of these functions on the same graph. They just each have different x values. For example 2, we have 4 different functions that we are graphing on the same graph. So first of all, we have f of x equals 1. We have f of x equals 2, f of x equals 3, and f of x equals 4. So we're going to graph each of these functions on the graph. So again, we need to pay attention to where our x values are located. So if we start at f of x equals 1, we're going from 0 to 1, and 0 is included in the graph. So again, we're looking at our x values. We're going to start at 0, and we're going to go to 1. So the graph of f of x equals 1 is in this shaded area. So if we think about this as y equals 1, know that this is a horizontal line like we looked at before because it's y equals. So y equals 1 is a horizontal line through y equals 1. So at 0, x equals 0, we know that it's or equal to because we're looking at our boundaries. So it's going to be a closed circle. And the other side is going to be an open circle because it's less than. And we're going to draw our horizontal line connecting those 2 points. Our next function, f of x equals 2. So we're going up to 2 on the y-axis. Now again, look at your boundaries. We're going from 1 to 2, and 1 is included. So again, it's going to be this shaded area. You don't have to shade these in on your notes. It's just to kind of look and see where our function is going to be located. So for f of x equals 2, remember that's a horizontal line through y equals 2. So at x equals 1, we're going to have a closed circle. Because again, if we look at our boundaries, we have or equal to, so it's a closed circle. And then on the other side at x equals 2, it's going to be an open circle. And again, this is a horizontal line through y equals 2. The third function, again, we need to look at our boundaries. So we have 2 is less than or equal to x is less than 3. So this is going to be from 2 to 3 on the x-axis. So again, in this shaded area is where our graph is going to be. So f of x equals 3 we know is again, a horizontal line through x equals 3. At 2, it's a closed circle, because again, it's or equal to. At 3, it's an open circle, because it's just less than. And again, it's our horizontal line. And the fourth function, notice we're going from 3 to 4 on the x-axis. So again, it's going to be in this shaded area. Again, you don't have to shade these in your notes, but just so you can visually see. So again, our function is y equals 4. So on the y-axis at 4. And again, we're starting at x equals 3. It is less than or equal to. So again, it's a closed circle. And on the other side at 4 is an open circle. So we're going to connect those. And that is our piecewise function. Now notice that this graph looks like steps. And this is called a step function. Again, it gets its name because it looks like steps. So again, we can have multiple different functions and we can graph them all on the same graph. We just have to watch out for the boundaries in which x values are included in each function. For example 3, we're writing an equation for the piecewise function shown on the graph below. So now we're taking the graph and we're finding the equation of each of these functions. So let's Let's start with this part of our graph. Again, I'm just going to shade it in so you can see where we are working with. If we look at our x-axis, notice we're starting at x is -1, and we're going to anything less than -1. So we need to find the equation of this line right here. So to find the equation of the line, remember the first thing we need is the slope. We can find the slope by looking at the points on the line. They give us 2 points, so we can find the slope by finding our rise and our run. So if we go up 3 and over 2, we know that that is our slope. Now they also give us 2 points on the line. So given the slope and a point on the line, we can find the y-intercept. So I'm going to use -3, 0, just because it's easier to work with. And I'm going to plug into point slope form. So y minus, our y value is 0, equals m, which is 3/2, times x minus a -3. Again, I want this in slope-intercept form. So y equals 3/2 x plus 3. So this is y equals 3/2 x plus 3 times 3 is 9, so 9/2. So this is the equation for the first part of our graph. So f of x equals 3/2 x plus 9/2. Now we need to look at our boundaries. Notice where our graph starts. Notice where our graph starts here at -1, 3. It is an open circle, so it's not or equal to. And notice that our graph is going to the left of that, so it's less than. So our boundaries for this function are going to be x is less than -1. Now if we look at the second part of our graph, so this one right here, notice it's a horizontal line through y equals -1. So the second equation for our graph is f of x equals -1. And if we look at our x values, again our graph starts at x equals -1. It was a closed circle, it is a closed circle, so it's or equal to, and it's anything greater than that. So our boundary for f of x is -1. is going to be x is greater than or equal to -1. So again, it's important to look at your boundaries. That will determine your x values, and you need to find the function or the equation for each part of your graph. Our last piecewise function has 3 different parts to it. So we're going to start with this equation right here. So our red equation, again, if we look at the graph, we can first find the slope. And I'm going to label this number 1. So the slope of this graph, we go up 2 and to the left 1. So up 2, left 1 will be 2 over -1, which is the same as -2. So our slope is -2. The second thing we need is our y-intercept. Now if we look at our graph here, our y-intercept is right on our graph. We can see that. So we know that this graph crosses the y-axis at +2. So that is our b, or y-intercept. So the equation for this graph is y equals -2x plus 2. Now we're going to look at the second line on the graph. It's this one right here. So again, we want to find our slope. Notice we are going up 1 and over 1. So our slope is a +1. And our b value, there's a couple different ways we can find it. First of all, if you finish or continue this line down to the left, we know that our slope is 1. So we can go down 1 to the left 1 to get to the next point on the graph. And that will show us that our y-intercept is -3. You could also use a point on the graph to find that y-intercept as well. But this one's pretty easy to see on the graph that our slope-intercept is -3. So the equation for this part of our graph is y equals x, or 1x, minus 3. Now the last part of our graph is just a closed circle at 1, -1. Now I want you to think about this for a second with the previous examples. Whenever we had a horizontal line, I want you to think of this as a horizontal line that is simply a point. Okay, so think about what this horizontal line would be through the point on the graph here. If we were to draw a horizontal line through this point, we know that it would be y equals -1. So this point is y equals -1. And we're going to talk about what the boundaries look like for that in just a second. So now that we have the equations for all 3 parts of our line, we're going to write all the equations together as a piecewise function. So again, this is f of x equals, our first equation was negative 2x plus 2. Now we need to look at our boundaries. We have an open circle at x equals positive 1, and our graph is going to the left of that, so less than 1. So our boundary is going to be x is less than 1. For our second function, we have again an open circle at positive 1, and our graph is going to the right. So our equation is x minus 3, and our boundary is x is greater than 1. Again, it's not or equal to because it's an open circle. And our graph is going to the right, so that's what makes it greater than. The last one we want to look at is y equals negative 1. Now notice that this is just a point at x equals negative 1. So negative 1 is our last function, and our boundary is just x equals 1 because it's just one point at x equals 1. So again, we can have multiple pieces on the graph. We just have to look at the function for each piece of the graph and determine what the boundaries are for each.